Hello learners, this is Education Online program. I'm teacher Lily. I'm going to teach you chemistry, and our topic today is combined gas law. So here if you said combined gas law, it means we are going to combine the Vals law and Charles law together to give us this third gas, which is known as the combined gas law. So in this case, it is very important for us to calculate the volume when the pressure and the temperature is given. So when the pressure and the temperature is given, then we can find out the volume of any given gas. So in this case, we have the combined gas law. So learners, we need to know that this is combining the Vals law and the Charles law. So you know what has happened in Charles law and what has happened in Vals law. So here we need to remember that our subject is chemistry. So here this combined gas law, actually it is combined, the combination, this is the combination of Vals law and Charles law. So here Vals law and Charles law, there are different gas laws, and the first one, which is Vals law, is actually telling us that when you keep the temperature constant, then you will have the pressure and the volume changes. So when you, in the second one, the Charles law states that when the pressure is kept constant, then there is changes in temperature and the volume. So the temperature here is known as the absolute temperature. So when you combine these two together, so it means we are going to have the three constants, or the three terms here: the volume, the pressure, and the temperature, all combined together. And here it is very important for us to calculate, for calculation of the volume of any given mass of a gas. So here we shall have to say that Vals law states that we have the volume is inversely proportional to the pressure. And also we have to say that in Charles law, we are going to say that the volume is directly proportional to the pressure. Is directly proportional to the temperature. So we shall have the temperature as it is directly proportional to the volume. So in this case, with the Charles law, we say that pressure, when at constant pressure, and the Vals law, it states that the volume is indirectly proportional to the pressure when you keep the temperature constant. So when the temperature is constant, then you shall have the volume and the pressure are inversely proportional to each other. So when the volume is directly proportional to temperature, then we have the pressure was kept constant. So combining these two together, we can say that volume is inversely proportional to the temperature over the pressure. And here we shall say that is equals to, so this volume here will be equals to, and this will be, so we shall have volume is equals to the constant, which is K, and we divide by the temperature. We multiply by the temperature, and we divide by the pressure. So when we combine these two laws together, then we shall see that the Vals law, which actually states that the volume is indirectly proportional to the pressure when we kept temperature constant. This is Vals law. So with the Charles law, that a volume is directly proportional to the temperature when the pressure is kept constant. So we have to combine these two together, then we shall have the volume is indirectly proportional to the temperature and the pressure, and so we can say that the V will be equals to the constant, which is K, then we multiply by the temperature and we divide by the pressure. So here we shall say also that therefore this temperature, this pressure and the volume will cross multiply, and it will be equals to the constant, and we divide by the temperature. So we shall say that this will be equals to P, which is the volume, and then the pressure, and we have the P is representing the pressure, and then V is representing the volume, then we divide by the temperature, will be equals to, well, this is when there is constant, it's constant for any fixed mass of a gas. For any fixed mass of a gas, so we shall have the pressure and the volume over the temperature are constant. So hence we shall have that P1 V1 over T1 will be equals to P2 V2 over T2. So this is known as the combined gas law. So this is now the formula for the combined gas law, which is pressure 1, volume 1, and over temperature 1. These are all known as the original temperature, original pressure, and original volume is equals to the final pressure multiplied by the final volume, then divide by the final absolute temperature. So this is giving us the combined gas law. So here this is very important when we are calculating for the volumes under the two sets of conditions respectively. So we shall have this equation is useful in calculating the volume of a fixed mass. So this equation, as I said before, that is very important in calculating the volume of a fixed mass of any dry gas. So for example, we can have a gas occupies 100 centimeter cube at 15 degrees centigrade, and we have 750 millimeter of mercury pressure. So what would be its volume at STP? So this is a standard temperature and pressure. So the standard temperature and pressure, so we need to consider these conditions of the volume under the standard temperature and pressure. So if a gas occupies 100 centimeter cube, so this will represent it as volume 1, which is the original volume, at 15 degrees centigrade, which is temperature 1, or absolute temperature 1. So, and 750 millimeters of mercury, which is represented as pressure 1. So what would be its volume at S.3? So you need to remember that temperature at a standard temperature, it has the value of 0 degrees centigrade, and this, when you convert it into Kelvin, then we shall have 273. So here given that at the standard temperature and pressure, we shall have a standard pressure. The standard pressure is 760 millimeter mercury. So at the standard temperature, at the standard pressure, at the standard temperature, standard temperature is 0 degrees centigrade. So we convert it into Kelvin. So remember that this is, we are using absolute temperature or Kelvin scale. So we shall have to add it into 273, then we shall have 273 Kelvin. So this 273 Kelvin, when we add it to 0 degrees centigrade, will give us this value. So in this case, we are going to have a solution for this, and then we find out which one is needed in these problems. So we shall have to note down the temperature, the volume, and the pressure, which are original, and then we find out the finals. The final temperature, the final volume, and then the final pressure. So, but what is needed here is the final volume. So remember that the combined gas law is very important for getting the volumes of any dry gas. So in this case, we need to remember that temperature 1 is 15 degrees centigrade, and we add it into 273. So we shall have temperature 1 will be equals to 15 plus 273 K. So when you add this, will give us 288 Kelvin. So we have changed it into Kelvin scale by adding 273. So we have also to remember that volume 1 is equals to 100 centimeter cube, and volume 2 is unknown. We have temperature 2, which is the standard temperature, is equals to 273. So here we have to get the pressure. Pressure 1 is what? Is 750 millimeters, and pressure 2 is 760 millimeters mercury. So we have to remember that this, we are going to apply it into the formula, which is pressure 1 volume 1 over temperature 1 is equals to pressure 2 volume 2 over temperature 2. So we shall have to apply this by saying that temperature 1, volume pressure 1, here pressure 1 is given as 750. Then we multiply by volume pressure volume 1, which is 100 centimeter cube. So we divide by the temperature, which is temperature 1. So temperature 1 for this matter is 288. So this will be equals to pressure 2, which is 760, multiply by, we have volume 2, which is unknown. Then we divide by temperature 2, and here temperature 2 is given by 273. So we cross multiply 273 by 750 multiplied by 100. Also multiply 288 by 760 to get volume 2. So volume 2 will be equals to 750 multiplied by 100 multiplied by 273. Then we divide by 288. We multiply by 760. So here we shall have the volume 2 to be equals to, therefore say volume 2 will be equals to 93.554. So we have, this is the new volume. So learners, we have seen that volume 1 was 100 centimeter cube, but when we come to volume 2, it has changed from 100 to 93.54, which means that the volume has been decreased. So the volume decreased at constant temperature and pressure. So in this case, we have find out the second volume, which is represented by 93.54 centimeter cube. So if you have seen all these changes here, we have 15 degrees centigrade. You need to add it into 273, and it will give us the values in Kelvin scale. So we have temperature 2 is 0 degrees centigrade. So when you add it into 273, then we shall have the value in Kelvin scale. So in Kelvin scale, it means that we have changed the 0 degrees centigrade into the Kelvin scale. So we have to go ahead and have another example, and here the other example is, we are going to see that how we go ahead with the formula, and we see how to get the volume of any given dry gas. The volume of any given dry gas, then we shall have to find out through the combined gas law. So here the combined gas law is, we are going to see that this is represented by having a gas occupying, so example 2, we have a gas occupies 78 centimeter cube. A gas occupying 78 centimeter cube at 17 degrees centigrade and 740 millimeters of mercury at pressure. So this, at what you are asked to calculate the temperature which will occupy, we shall have to say that this is represented, and we shall say that at what temperature will it occupy 100 centimeter cube at 760 millimeters of mercury pressure. So we are representing the pressure here to be 760 millimeters, which is represented by the mercury scale. So we shall say that the solution is, we need to remember that the formula is pressure 1 volume 1 over temperature 1 is equals to pressure 2 volume 2 over temperature 2. So here we are going to say that pressure 1 is equals to, so if you read this statement here, a gas occupies 78 centimeter cube. It means this is volume 1 is 78 centimeter cube. So pressure 1 here is 740 millimeter, and we have the temperature here. The temperature 1 is going to be 17. Of course we need to change it into Kelvin, plus 17 plus 273. So we shall have the temperature here in Kelvin. So here, by representing the Kelvin scale, we shall have that this is 290 Kelvin. So also we need to see that the pressure 2 is represented here as 760 millimeters of mercury. So volume 2, so we shall see that volume 2 here is 100 centimeter cube. So temperature 2 is what is required. So at what temperature? So it means that here what is required is the temperature 2. So we have to put these values into the formula, and we remember it as we put it down here. So we shall have pressure 1 is 740 multiplied by volume 1 is 78 centimeter cube, divided by temperature 1 is 290, and here is 290 Kelvin, which is equals to pressure 2 is 760, and we multiply by 750 multiplied by the volume, which is volume 2, and here volume 2 is 100 centimeter cube. Then we divide by temperature 1. So here temperature 1 is temperature 2, sorry, is the one which is unknown. So temperature 2, we are going to get it by cross multiplying, and we divide by the other value and will give us temperature 2. So here we shall have temperature 2 will be equals to 760 multiplied by 100, 790 multiplied by 100, multiplied by 760. So we shall have the temperature, which is temperature 1, and then volume 2 and pressure 2. Then we divide by pressure 1 multiplied by volume 1. So we shall, it is going to be equals to 397 Kelvin. So here this is the temperature which is required in these problems. So we have seen that the gas occupies 78 centimeter cube at 17 degrees centigrade. So this has a pressure of 740, and here we represent it as pressure 1. So at what temperature will it occupy 100 centimeter cube at 760, which is the pressure? So in this case, what is required or what is needed is the temperature. So we shall go ahead and put down the formula. In this case, we have all the three items: the pressure, the temperature, and the volume indicated. So you go back and remember that this is the combined gas law. It is not Charles law alone, or it is not Vals law alone, but it is the combined Charles and Vals law. So we calculate it out and we get what is required. So in this case, what is required is temperature 2, which is the absolute temperature, which is represented by Kelvin scale, and it is 397. So 397, and the temperature one is 290. It means it has increased from 290 to 397. So with these learners, we have known all the gases, and we have come out with the combined gas law, and we know how to get the combined gas law for what is missing in the problem. So in this case, we have combined the Vals law with the Charles law, and we said that the Charles law is actually representing that when you keep a pressure constant, then you will have that the temperature and the volume, they are directly proportional to each other. So when you keep the pressure constant, then the temperature constant, then we'll have the volume and the pressure, they changes. In this case, we say that this is Vals law. So in this, we have come out to the end of this lesson, and we remember all the gases law, and which come out from the kinetic theory of gases. We say that the gas is a small molecules which have a very small distance between their molecules that make them to collide with themselves, and also with the container or the walls of the container that are kept in. So with this, we have come to the end of this lesson. So thank you very much for listening.